Okay, let's have a look here. You got Z1 and Z2. You have to calculate a few things here. Number one, their product, Z1 times Z2, that's going to equal 2 plus 3i times 3 minus 2i. Oh, sorry, 2 plus 3i and 3 plus 2i. 2 plus 3i and 3 plus 2i. Okay, so that's going to be 6 plus 4i plus 9i minus 6, which interestingly is 13i. 2. The conjugate of Z1, Z2. Well, we just calculate it right there, so it's got to be minus 13i. And then 3, Z1 conjugate, Z2 conjugate. Well, that's the same thing as Z1, Z2 conjugate, which is minus 13i. So, yeah, and if you wanted to check that, you could kind of see it here. If these were both minuses, oops, if that was a minus and that was a minus, you would get here 6 minus 4i, and then here, if that was minus 3i, that would be minus 9i, and that would be a plus so you would have had 6 minus 4i minus 9i plus 6. So that would have the minus 6, 6 minus 13i. Maybe I should multiply it out just to confirm that I'm not making any mistakes. 2 plus 3i times 3 minus 2i. That's 6 minus 4i. Oh, I forgot to conjugate the first one. Two minus 3i times 3 minus 2i. That'd be 6 minus 4i minus 9i plus minus 6 then. So that's minus 13i. Yeah. So like it's the same. I doubt that they wanted to see that. I doubt it. So 13 minus 13. And yeah, okay, so let's have a look at part B. The point AB on the diagram have the coordinates x, y, 1, 0. Find the distance AB and show that this distance is equal to the modulus of z minus 1. Okay, well, we can get the distance if we want just from Pythagoras. So if we just draw a triangle here, that side would be x minus 1, and that side would be y. So the distance there, we have d squared equals x minus 1 squared plus y squared. So that's equal to x squared minus 2x plus 1 plus y squared. So I guess d will be the square root. See, I'm not sure if I need to expand it, but I will. Now, if we calculate the modulus of z minus 1 we get the square root, well, let's just get the z minus 1 part first. That's the modulus of x plus iy minus 1, which is the modulus of x minus 1 plus iy, which is the square root of x minus 1 squared plus y squared, which is the square root of x squared minus 2x plus 1 plus y squared, which is equal to the d. So show that the distance, find the distance and show that this distance is equal to the modulus of z minus 1. Okay. D is the distance AB. Okay, and then the last part here, illustrate on an Argand diagram the locus of z for which z plus, okay, so let's draw an Argand diagram. 1, 2, 3, 4, 1, 2, 3, 4. I, 2i, 3i, 4i, minus I, minus 2i, minus 3i, minus 4i, etc. You get the idea. Okay, so we'll just change this into 1 less than or equal to modulus of z plus, or sorry, minus 2 plus 0i less than or equal to 2. So this is the distance between z and the point minus 2, which is here. So if the distance between z and this point was less than or equal to 2, well, that's just a circle. But it has to be more than or equal to 1, so it looks like it's an annulus. So it's this region here. This is the region. You can take an example here, like you know, if the z was like, say, here, then that's more than 1 unit away, but less than 2 units away. So you can see why all these points here in this circular shape, this annulus, is between 1 and 2 units away from the minus 2. Yeah, you can test it out if you want to. So like if you test, for example, let's say minus 3.5. So the modulus of minus 3.5 plus 2, if you test it here, that's equal to the modulus of minus 1.5, which is equal to 1.5, which is between 1 and 2. So we can see that it works. Okay, I think that's everything for this question.